Hello, my name is Emilio Reyes Monterrubio, and my teammates are Sofia Sánchez Bolarin, Rafael Vinueza Jaramillo, and student Arat Rios. And we're going to present you a resume of our solution to the problem scenario for the signature analysis of electrical circuits. The main objectives of this project are knowing the actual status and the potential of photovoltaic energy in Mexico, knowing the operative principles of those systems, using measurement tools for obtaining voltage, current specs, and the specifications of photovoltaic modules connected in parallel and series circuits. Also, identify factors that affect the development of photovoltaic systems. The current capacity of solar-based energy generation is near to 5,000 megawatts, and according to the Mexican Solar Energy Association, ASOLMEX, there has been an increase of photovoltaic generation during 2019, coming from 3,075 megawatts to 4,057 megawatts by the end of the year. The solar energy potential of Mexico is considered one of the world's largest. It's estimated that each square meter can generate by about 5 kilowatt hours per day, which in the total Mexican territory is estimated to be equivalent as much as 50 times the national electricity generation. And according to the National Transition to Renewable Technological Strategic Commission, only in the roofs of the 29 largest cities in the country, there are 81,000 megawatts of potential energy that can create and satisfy our needs of energy. The forecast of energy in Mexico are with high expectations. According to the Ministry of Energy, this year photovoltaic capacities had an increase of around 3.4 gigawatts and an expansion that will continue to 2021. Even though the decrease of the acceleration of the expansion in this sector, the Mexican market for this clean energy won't stop offering opportunities to the companies that put this effort to bring solar energy to every home in the country.
In the section of the problem situation, what we did was to address a little issues about what is a photovoltaic cell, photovoltaic module, the elements of the modules. We did this to be able to keep in mind the knowledge about the meaning of each element. We carried off the investigation on how to obtain the voltage in open circuit and in a short circuit of photovoltaic module. Seeing it is important for the experiments that will be carried out, then we investigate how the current voltage AB and power voltage PV characteristics of a photovoltaic module and the maximum power point are obtained experimental. Finally, we investigate how to calculate the energy produced by a photovoltaic system. These investigate topics were of immense importance to able to apply them in the experimental situation. Each one is involved in some part of the experiments.
Regarding the simulations in multism, as it can be seen by the graphs of IV and PV, for all of the simulated situations, their forms are similar. What can be appreciated immensely is the effect that the type of connection has on the currents and voltages, as well as the effect of covering partially one of the modules. Regarding the current, it is shown that when the cells are connected in parallel, the current rises. This can be clearly evidenced by the fact that the short circuit current on the system connected in parallel is exactly double than the short circuit current of the system connected in series. A similar affirmation can also be made about the voltage. The open circuit voltage can be seen rising due to the fact that more elements are connected to it in series. This behavior is coherent with Ohm's laws and Kirchhoff's laws, since in a parallel array a node is created, the currents are added, and when they are in series, they form a loop which maintains its current throughout. In the case of when a module is partially covered, it is seen on the graphs that the current drops. This happens because the photovoltaic cells are getting less radiation, therefore producing less current. This also affects the PV curve, lowering its maximum, since the formula heavily relies on current to calculate it. It should also be noted that the voltage in this case doesn't change.
Experimentations, many things were very clear. These types of experiments prove how useful the tests are, and this helps us to know the performance of the cells we use during the experimentations, the technical aspects, and how to make a choice about how to add the PV system to a home network. Through the report, I had some issues and problems encountered during experimentation, because at first I was using light of a lamp, but then I had the opportunity to use sunlight. So it increased the voltage and the current. And after that, the experimentation was clearer, so I could obtain the curves with a better range of parameters. During the experimentations, I also reaffirmed how cells are connected in parallel and series, and we can denote concepts that we learn in class. So it was a good form to finally understand how those types of circuits work. Another issue that we presented was that in the city that I live, which is Pachuca, the sun isn't constant. So I had to wait until the sun was constant to take a measurement, because if not, the results wouldn't be exactly. And I took a lot of time to do that because there was cloudy day, so we have to wait until the sun was in a correct position. And at the end of everything, we got the results we wanted, and we made the graphs with the measurements that were took during the experimentation. And at the end of everything, we can know how to connect this type of circuits in our home, which was the project about. And it's important to know how to do this because we can know how to get a specific current and a specific voltage that we can use at home.